Hi. Now let us start with the permutation combination, and the most important concept here is a placeholder. Here, this box or something, we generally don't say it is a box, but you can say it is a placeholder concept. This placeholder concept is that you have to imagine a box. In some situations the box actually may not be there, and you have to see that how these boxes can be filled up, and you have to see this arrangement, that is the number of ways this box can be filled up is known as an arrangement or permutation. This permutation is basically an arrangement. Arrangement means that the sequence in which you arrange them is important. Now let us see this case, easy case, that there are say two boxes and there are 5 toys. So here I will not draw animals, but say this is toy 1, toy 2, toy 3, toy 4 and toy 5. They are all lying in on the floor. They are on the floor, and you have to fill up these 2 boxes, and only one toy can get into one box. Now, while solving permutation combination problems, it's an extremely important step for you to understand that you should not unnecessarily use formula. Here, this problem can be solved by formula, but I don't want to tell you the formula at the beginning. I want to tell you the formula at the last. I want to emphasize on the concept that how this problem can be solved without the formula, and that's very important for you to understand. You have to imagine that you are picking up a toy and putting it in a box, and only one toy can get in one box. So you see that there are 5 toys in front of you. There are 5 toys in front of you, and you can pick any one of them and put it here. So naturally this box can be filled up in 5 ways, because any one out of the 5 can be picked and put here. Next, into, that means every time you do that, it can be a toy 1, toy 2, or it can be toy 1, toy 5. There can be so many possible ways in which these boxes can be filled up. That means what goes inside the box is a toy, and outside these numbers are the number of ways to fill it up. These are number of ways to fill it up. This is not exactly what 5 doesn't mean that T5 is here. 5 is the total number of ways the box 1 can be filled up. Now, once out of the 5 toys you pick up one and say, assume that T2 is filled up. Just assume that T2 is gone. That means T2 is inside the box, which means that you will be remaining with 4 more toys, and you can pick up any one out of 4. Any one out of these 4 can be picked up and put in here. So without getting into any formula, you just imagine the number of ways to fill it up. So this symbol stands for number of ways to fill the boxes. In this case, is straightforward, 5 into 4. Now, this is the concept of placeholder and a filling up of a box. We didn't get into any formula at all. We can do this by formula also. And here, this is an arrangement which is known as permutation. And you have a formula here. So we will have something known as NPR. And this particular arrangement is actually 5P2, because there are 2 boxes and 5 things are being filled up. So 5P2, and this comes out to be actually factorial 5 by factorial 5 minus 2. The reason is that NPR stands for factorial n by factorial n minus r. Now that is a different thing. I am not emphasizing on it. In fact, I have solved the problem without the formula, if you see, and this comes out to be factorial 5 by factorial 3. And the factorial 5 by factorial 3 can be written as 5 into 4 into factorial 3, and this is factorial 3. Factorial 3 cancels, so 5 into 4, and you get the same result, 5 into 4. Now, these are the different ways of looking at it. NPR, because it is a permutation, it is an arrangement, because which toy is first and which toy is second, that matters. That is, T1, T2 and T2, T1 is not the same thing. T2, T1 is that the left box has T2 and the right has T1, because the boxes are unique. Imagine the boxes have different colors. like this is a blue box and this one is a white box, quite possible. So T2, T1 and T1, T2 is a different arrangement, and thus we tend to get permutation. Arrangement is for permutation. Permutation stands for arrangement. So you can use the formula NPR, and there are 5 toys and 2 boxes, so you are using NPR to do it, or 5P2 in this case to do it, and you have to remember that NPR is factorial n minus r. But just watch, and again I want to emphasize on the first point. This problem can be done without using the formula, and that is what I would like to emphasize on. And so I would like to solve another problem. The problem is very simple. Imagine that I have been given 9 toys. So I have 9 toys and I have 3 boxes, say. I have 3 boxes to be filled up. And these 9 toys are lying on the floor. And I am a small child who is trying to fill up these boxes, and only 1 toy can get into a box. Now I will imagine myself to just physically pick up a toy and put it in a box. I don't know any mathematics, I don't know any calculations involved. I only know that I have to pick up a toy and put it in the box, which means that out of the 9 toys, I can pick up any one and put it. So I can put toy 1 here, or I can put toy 2 here, or I can put toy 3 here, or toy 4 here. And as long as I know that I can fill it up in 9 ways, because I can, out of T1, T2, T3 up to T9, I can pick up any one toy out of 9 and fill the first box. So the first box can be filled up in 9 ways. Then obviously 1 toy getting in, I will be remaining with 8 toys, and I can pick up any 1 toy. That means 1 out of 8 toys I can pick up and put it here. So then second box, this is the second box, this is the third box, and I know that the second box can be filled up in 8 ways. Now if I have put up a toy here, if I have put up a toy here, after that I will be remaining with 7 toys, and I as a small child can just pick up 1 toy and put it in the third box. So 1 out of 7 toys, I can pick up 1 and put it here. And so this is 72, 8 into 9 into 7. Now we don't have to multiply this necessarily. If it comes to multiply, then you know how to multiply it. That's not, because I am a small child, so I don't know how to multiply, but I know how many ways I can fill up these boxes, and I know that this box, 3 boxes, can be filled up in 72 into 7 ways. So this is the way these problems are done.